Hello everyone. Today we will discuss the concept of bivariate and multiple regression setting. Now you might be thinking that why I have chosen this topic for today. In fact, many times students or researchers ask me when to apply multiple or logistic regression and how interpretation of multivariable setting is different from bivariate regression setting. Or in general, how simple linear regression or logistic regression is different from multiple linear or logistic regression. So, today I decided to answer this query. Before discussing about bivariate and multivariable setting, let's quickly review the concept of regression and when to apply linear regression and when to apply logistic regression. Regression establishes the mathematical relationship between independent variable or factors on outcome variable. Or regression can be described as a statistical tool utilized in fields such as housing and investing to predict the connection between dependent variable and various independent variables. Or we can say that the purpose of regression is to create a predictive model for the dependent attribute based on multiple input variables. That means in regression, we are trying to establish a mathematical relationship by to predict our outcome variable on the basis of information available to us. Okay. Next question is when to apply linear regression and when to apply logistic regression. So when our output is continuous or real valued quantities such as salary, weight or area, then we have to use linear regression. While in logistic regression, output is binary in nature. For example, heart attack, yes or no. In linear regression, we are trying to quantify in numbers like salary, weight, systolic blood pressure, um, healthcare expenditure. In logistic regression, we compute probabilities of event of interest like probability of heart attack. Now, the main topic of video is simple versus multiple regression setting. Okay, so when we have only one x variable, that means only one independent variable to answer y variable, then we use simple linear regression or simple logistic regression. So suppose I want to predict weight of individuals on the basis of their height. Then we can use simple linear regression. Why linear regression? Because outcome variable is weight, which is continuous in nature. And why simple? Because we are using only one x variable. Similarly, if I'm using more than one x variable, like x1, x2, x3, x4, x5 and so on, okay, then it will be multiple regression setting. That means if we want to predict weight on the basis of height, calorie intake, gender, and many other factors, say suppose stress score. So there are different scales which can measure stress. So if we can calculate the stress score, okay, so how, and let us also consider physical activity or duration of physical activity. Duration of physical activity and age. Okay, so as all of us know that whatever is happening in our life is not because of one cause. There are multiple causes occurring together to produce a particular effect. Okay, so same is the thing applying in multiple regression. In multiple regression, we are trying to figure out independent predictors or of our outcome. So instead of computing the effect of each factor on our outcome variable. Here we are trying to see what happen if we are adjusting all the things, and then how this combination of variables will affect our outcome variable. So suppose if we find height as significant factor to predict weight after controlling for calorie intake, gender, stress, duration of physical activity and age. So we can say that height is an independent predictor of weight. So this is how we have to interpret in case of multiple regression settings. If you have still any query, you can ask me. Please feel free to drop your query in a comment section of YouTube, or you can also reach me on my Gmail. Thank you.